Hello students, I am Dr. Sangeeta Sharma, your science teacher. Today we will be continuing with chapter 10 of your science book, that is light, reflection and refraction. In today's video, that is part 6, refraction of light, we will be understanding about refraction of light. Students, we know that basically light travels in a straight line, which is also known as rectilinear path of propagation. Now, when this light is traveling in a straight path in a medium, what will happen if the medium changes? Will the light continue to travel in a straight path or will it change its path? So, let's study refraction of light. Students, we might have observed that if we take a glass filled with water and we put a lemon inside it, then what we see is that the size of the lemon appears bit larger as compared to its original size. क्या होता है स्टूडेंट्स कि अगर मैं एक नींबू को एक पानी का जो ग्लास है, कांच का ग्लास है पानी से भरा हुआ, उस नींबू को मैं उसके अंदर डाल दूं तो क्या देखूंगी कि नींबू का जो साइज था, जो ओरिजिनल साइज था, उससे कहीं ज्यादा बड़ा वो नींबू दिखाई देगा जब उसको मैं पानी से भरे हुए कांच के ग्लास के अंदर डाल दूंगी। ऐसा क्यों होता है? आप लोगों ने स्विमिंग पूल भी देखा होगा स्टूडेंट्स। तो स्विमिंग पूल के अंदर जो है, सपोज कीजिए स्विमिंग पूल के अंदर 5 फीट तक या 6 फीट तक पानी भरा हुआ है, पर जब हम उस पानी में से स्विमिंग पूल के फ्लोर को देखते हैं, उसके लेवल को देखने की कोशिश करते हैं, तो हमें ऐसा लगता है कि उसका जो बॉटम है वो थोड़ा सा उठा हुआ है, यानी कि वो 5 फीट की या 6 फीट की डेप्थ नहीं नजर आती है। तो ऐसा क्यों होता है कि एक स्विमिंग पूल का जो फ्लोर है, जो उसका बॉटम है, वो हमें थोड़ा सा उठा हुआ नजर आता है। एक नींबू जिसको मैंने कांच के ग्लास के अंदर जिसमें पानी भरा हुआ था उसमें डाला तो उसका साइज बड़ा नजर आता है। स्टूडेंट्स, ऐसा क्यों होता है? 2 एग्जांपल्स और देखते हैं। अगर मेरे पास में एक पैटर्न है जिसके अंदर डिफरेंट कलर्स हैं और उसके सामने मैं एक कांच का ग्लास जिसमें पानी भरा हुआ है उसको रख देती हूं, तो मैं क्या देखती हूं स्टूडेंट्स कि वो जो पीछे का एक रेगुलर पैटर्न था वो डिस्टॉर्ट हो जाता है। यानी कि जो कलर्स जिस तरीके के थे, जिस तरीके का पैटर्न था, वो पैटर्न जो है डिस्टॉर्टेड, डिस्प्लेस्ड नजर आता है। आप देख रहे हैं यहाँ पे पीछे की तरफ जो है स्ट्रेट लाइंस के अंदर पैटर्न था, और जब मैं उसको एक ग्लास उसके सामने रख दिया है जिसमें पानी भरा हुआ है, कांच का ग्लास है, तो वो पैटर्न जो है वो डिफरेंट नजर आ रहा है। यानी कि उस पैटर्न के अंदर जो है डिस्टॉर्शन हो गया, डिस्प्लेसमेंट हो गया और वो पैटर्न एक्चुअल पैटर्न से अलग नजर आ रहा है। इधर एक और एग्जाम्पल हम देख रहे हैं कि अगर एक कांच के ग्लास के अंदर जिसमें पानी भरा हुआ है हम एक स्ट्रॉ डाल दें, तो स्ट्रॉ जब डालते हैं स्टूडेंट्स तो यहाँ पे क्या नजर आ रहा है कि ये जो स्ट्रॉ है जो कि इस तरीके से होनी चाहिए थी वो इस तरीके से नहीं होकर और वो कहां पर नजर आ रही है? वो यहां पर नजर आ रही है। यानी कि जो पॉइंट था या जो लाइन थी जहां से एयर और पानी मिल रहे थे वहां से वो स्ट्रॉ टूटी हुई नजर आती है। तो ये वाला जो पॉइंट है जहां पे वो स्ट्रॉ टूटी हुई नजर आ रही है, वो कौन सा पॉइंट है? जहां पे एयर पानी के साथ मिल रहा है। तो जो हमारी स्ट्रॉ जो कि स्ट्रेट होनी चाहिए थी वो स्ट्रेट नहीं होकर और वो अपनी जगह से टूटी हुई यानी कि डिस्प्लेस्ड नजर आती है। तो ऐसा क्यों होता है स्टूडेंट्स? तो ये सारे एग्जाम्पल्स हमें ये बताते हैं कि लाइट जो है जब वो एक मीडियम से दूसरे मीडियम में जाती है तो वो अपनी स्ट्रेट पाथ जिसमें वो ट्रैवल कर रही होती है उससे थोड़ी सी डिस्प्लेस हो जाती है, यानी कि वो अपना पाथ चेंज कर लेती है। नाउ स्टूडेंट्स, दिस बेंडिंग ऑफ लाइट व्हेन द मीडियम चेंजेस इज नोन एज रिफ्रैक्शन ऑफ light. So students, what is the definition of refraction of light? Refraction of light, it is the phenomenon of bending of light as it passes from one medium to another. So this phenomenon by which the light gets bent on changing the medium is known as refraction of light. तो स्टूडेंट्स, जो लाइट रे स्ट्रेट चल रही थी एक मीडियम के अंदर, वो लाइट रे स्ट्रेट नहीं चलेगी जब मीडियम चेंज हो जाएगा, यानी कि वो अपना स्ट्रेट पाथ जो है उसको चेंज कर लेगी मीडियम चेंज होने पर। तो आइए अभी हम देखते हैं कि ये रिफ्रैक्शन ऑफ लाइट जो है वो किस तरीके से होता है। सो स्टूडेंट्स, हियर आई हैव टेकन two mediums, medium 1 and medium 2, and I have tried to show the different media by using different colors. So this is the lighter blue and this is the darker one, and the lighter color is used for medium 1, which is a rarer medium here in our case, and the darker blue color is used for medium 2, which is denser as compared to medium 1. Now students, here we must understand that rare and dense are comparative terms which we will be using here, that a medium can be rare for one medium and it can be dense for some other medium. For example, if we understand, if we take water, then water is denser for air, but water is rarer for glass. So keep this in mind, that when I say rare medium or dense medium, then basically it is a comparative term. So here we have taken medium 1 as a rare medium and medium 2 as a dense medium. Now when a ray of light is incident on the interface. Now students, what is a interface? A interface is the line at which the two mediums are separating each other. So what we see is that here I have drawn a yellow line which is called interface. So if I draw a normal at the point of incidence, the incident ray is incident at this point, and if I draw a normal n dash perpendicular to the interface, this line n dash is called normal. It is perpendicular line and it is perpendicular to the interface. Then what we observe is, students, that the ray which is incident, instead of moving in a straight path, it actually gets bent and it bends towards the normal. Now what I see here is, students, that the incident ray of light, which is incident at some angle I, instead of moving straight, it gets bent and it bends towards the normal. Then this ray of light is known as the refracted ray, and this phenomenon of bending of light as it passes from one medium to another is called refraction. Now students, here keep in mind that the incident ray will make an angle I with the normal, and similarly the refracted ray makes an angle R with the normal. This is known as angle of incidence I, and R is known as the angle of refraction. Keep in mind, the angle of incidence is always taken as the angle between the normal and the incident ray, and the angle of refraction is taken as the angle between the refracted ray and the normal. Now students, this bending of light takes place when the medium changes. Now why does this ray of light bend? Yes, we know that the medium is changing, but what is the cause? So students, the reason why the light ray bends when the medium changes is the change in speed of light. That is, the light is having different speeds in different medias. We have, students, the speed of light is given as small c, and small c is the speed of light in vacuum. So when there is no medium, the speed of light is maximum, and it is given by c is equal to 3 into 10 to the power 8 meters per second. Now when light enters some other medium, then it changes its path due to the change in speed of light. So the root cause of refraction of light is the change of speed of light, that is, the light has different speeds in different medias. So the cause of refraction: speed of light changes when medium changes. Speed of light rays is more in rarer medium and comparatively less in denser medium. Now what we have written here, students, is that the speed of light changes when medium changes, and this is the cause of refraction. And the speed of light is more in rarer medium and is comparatively less in denser medium. इसे हम कैसे समझ सकते हैं स्टूडेंट्स? अगर आप भाग रहे हो हवा के अंदर यानी एटमॉस्फेयर के अंदर, है ना, नॉर्मली अगर हम दौड़ रहे हो और किसी स्पीड से दौड़ रहे हो, और अगर हमें कहा जाए कि पानी में दौड़िए, तो पानी में हमारी स्पीड जो है वो कम हो जाएगी या ज़्यादा? कम हो जाएगी। क्यों? क्योंकि एयर जो है वो तो रेयर मीडियम है, वहां पर दौड़ना आसान है, और पानी जो कि डेंस मीडियम है उसमें दौड़ना मुश्किल है। तो स्टूडेंट्स इसको यूं समझ सकते हैं कि लाइट के साथ भी सेम होता है। लाइट एयर के अंदर या वैक्यूम के अंदर तो आसानी से दौड़ पाती है, चल पाती है, प्रोपोगेट कर पाती है, पर अगर उसके आगे पानी आ जाए या ग्लास आ जाए तो उसकी स्पीड जो है वो कम हो जाती है। कम क्यों हो जाती है? क्योंकि सामने वाला मीडियम जो है वो डेंस होता है। तो हम क्या समझते हैं स्टूडेंट्स इस बात से? इस बात से हमें ये समझ में आता है कि स्पीड ऑफ लाइट जो है वो रेयर मीडियम में ज़्यादा होगी और डेंस मीडियम में कम होगी। यही रीज़न है स्टूडेंट्स जिस कारण से हमें बिहेवियर लाइट रे की बेंडिंग का समझ में आएगा। तो यहां पर देखते हैं स्टूडेंट्स दोनों अलग अलग केसेस के लिए कि लाइट रे जो है उसकी बेंडिंग किस तरफ होगी। ये कौन डिसाइड करेगा? ये डिसाइड करेगा स्पीड ऑफ लाइट। सो स्टूडेंट्स हियर वी हैव टेकन again two medias, one a rarer medium and one is a denser medium. In this case I have taken rarer medium on the top and denser medium on the bottom. Now here what happens is students, when a ray of light is incident on the interface separating the two mediums, then instead of going straight the ray moves like this. After refraction the ray moves like this. Now what is happening here is that the ray of light is bending towards the normal. Now why does this happen? Of course the speed of light is changing, but the speed here is more as compared to the speed in the denser medium. So what happens is students, as the light ray reaches the interface the speed reduces. So when the speed reduces, then instead of going along this straight line the ray of light goes along this path, because the speed of light has reduced. So the refracted ray bends towards the normal n dash. So here we have given that the refracted ray moves towards the normal when the light ray travels from a rarer medium to a denser medium. Now students, let's understand, if we have a denser medium first and a rarer medium after that, that is the light ray is entering from denser medium to rarer medium, then is it going to behave in the similar manner or its behavior changes? So what we see here is students that when a ray of light is incident at the interface of two medias in which this medium is denser and this medium is rarer, then instead of going along the straight path it moves like this, it comes out like this. So why it comes out like this? Because the medium is changing, so the speed is changing. Now students, here the speed was less as compared to the speed here. Now since the speed has increased, so the ray of light, instead of going this way, it goes this way. So this is the refracted ray, and what we see is that the ray of light has bent away from the normal. So students, what we see is that if a ray of light is moving from rarer to denser medium, it will bend towards the normal, and if a ray of light is moving from denser medium to rarer medium, it will move away from the normal. So the refracted ray moves away from the normal. So this is what is known as refraction of light, that is the bending of light when the medium changes, and the cause of it is the change in speed of light. Now students, let's understand refraction through a rectangular glass slab. Now here students, we have a rectangular glass slab A, B, C and D. Now this A, B, C, D is a glass slab, that is, it is made up of glass, that I have shown you with a blue color. So this is a glass slab. Now as compared to air, glass is going to be a denser medium. So students, here we have air, which is a rarer medium. Here again we have air, which is a rarer medium. Keep in mind, here we are using rarer and denser as a comparative term. Now students, here in order to understand the refraction through a glass slab, we must first understand that here we are having two interfaces. How two, students? Here, when the ray of light will be incident at this portion AB, this is the first interface. The interface here is for air medium and glass medium. And CD is again one more interface, which is an interface between glass and air. So the ray of light incident on the glass slab has to undergo refraction at these two interfaces AB and CD. So there will be two refractions over here. Now let's see the behavior of light when it gets refracted through a glass slab. That is, when it undergoes two refractions, how does the light ray behave? So students, here we have a incident ray, and the ray is incident, say at this point. So we have drawn a normal at the point of incidence, and the incident ray is making an angle I with the normal. Now since here the light ray is moving from a rare medium to a dense medium, so it will move towards the normal. So in place of going straight, the ray of light gets bent towards the normal. Now the angle of incidence was, say, I, and the refracted ray makes an angle R with this normal. So R is the angle of refraction. Now students, this refracted ray when reaches this point, that is, again it sees a change in medium because CD is again a interface. Now here the ray of light is entering a rare medium from a dense medium. That is, the light ray is moving from a dense medium to a rare medium. So instead of going straight, it will move away from the normal. If it would have gone straight, then it would have gone like this, but instead of going straight, the ray of light gets bent away from the normal. So it comes out like this. This ray of light has bent away from the normal, and this ray of light is known as the emergent ray. This was the incident ray, this was the refracted ray, and this is the emergent ray. Emergent ray is the ray which has come out of the glass slab. Now what we see here is, students, that the initial path of the incident ray, this is the initial path of the incident ray, and this is the emergent ray. Now what we see, students, here is that these two rays are parallel to each other. That is, the direction of incident ray and the direction of emergent ray both are parallel to each other, and what we observe is that the emergent ray has come out parallel and it is displaced a bit, and this displacement is known as lateral displacement. So what we see here, students, is that when a light ray undergoes two refractions through a glass slab, then the emergent ray comes out parallel to the direction of the initial incident ray, and it is displaced a bit from the initial direction, and this displacement is known as the lateral displacement. Now students, when a light ray enters a glass slab, then the emergent ray is parallel to the incident ray, but it is shifted sideward slightly, which is known as lateral displacement. So what is lateral displacement? The perpendicular distance between the original path of the incident ray and the emergent ray. The perpendicular distance between the incident ray and the emergent ray is known as the lateral displacement. Now students, this lateral displacement also depends upon certain factors. So the factors on which lateral displacement depends. Students, the first factor on which it depends is it is directly proportional to the thickness of the slab. जितनी मोटी ग्लास स्लैब होगी उतनी ज़्यादा लेटरली डिस्प्लेस्ड होगी इमर्जेंट रे, यानी कि जो परपेंडिकुलर डिस्टेंस है इंसिडेंट रे की डायरेक्शन का और इमर्जेंट रे की डायरेक्शन के बीच में, वो जो डिस्टेंस है, वो जो डिस्प्लेसमेंट है, वो ज़्यादा होगा अगर थिकनेस ग्लास स्लैब की ज़्यादा होगी। तो ग्लास स्लैब के जो थिकनेस है वो डायरेक्टली प्रोपोर्शनल है लेटरल डिस्प्लेसमेंट के, या यूं कह लीजिए लेटरल डिस्प्लेसमेंट डायरेक्टली प्रोपोर्शनल है ग्लास स्लैब की थिकनेस के। इट इज डायरेक्टली प्रोपोर्शनल टू द एंगल ऑफ इंसिडेंस। जितना ज्यादा एंगल ऑफ इंसिडेंस होगा लेटरल डिस्प्लेसमेंट भी उतना ज्यादा होगा। थर्ड, इट इज डायरेक्टली प्रोपोर्शनल टू द रिफ्रैक्टिव इंडेक्स ऑफ द ग्लास स्लैब। जितना ज्यादा रिफ्रैक्टिव इंडेक्स होगा स्टूडेंट्स ग्लास स्लैब का, उतना ही ज्यादा लेटरल डिस्प्लेसमेंट होगा। और अभी थोड़ी देर में हम पढ़ेंगे कि रिफ्रैक्टिव इंडेक्स क्या होता है। फोर्थ पॉइंट, इट इज इनवर्सली प्रोपोर्शनल टू द वेवलेंथ ऑफ इंसिडेंट लाइट। इंसिडेंट लाइट की जो वेवलेंथ होगी उसके इनवर्सली प्रोपोर्शनल है, यानी अगर वेवलेंथ ज्यादा होगी तो लेटरल डिस्प्लेसमेंट कम होगा, और अगर वेवलेंथ इंसिडेंट लाइट की कम होगी तो लेटरल डिस्प्लेसमेंट ज्यादा होगा। तो इट इज इनवर्सली प्रोपोर्शनल टू द वेवलेंथ ऑफ light. Now students, let's understand first the laws of refraction of light. As we know that we have already done the laws of reflection of light. Now students, there the medium was the same and the light was bouncing back in the same medium. Here the medium is changing, but the ray of light after refraction has to follow certain laws, and that is known as laws of refraction. So here students, again we have two laws of refraction. As there was two laws of reflection, here we have two laws of refraction. So let's understand these laws. So the statement of the first law is that the incident ray, the normal to the interface of two transparent media at the point of incidence, and the refracted ray all lie in the same plane. Students, here the incident ray, the normal and the refracted ray, all the three lie in the same plane. This is almost similar to the second law of reflection. There also we had a similar type of law. Now here keep in mind that we are studying refraction, not reflection. Now see the second law, which is also known as the Snell's law. Now what does this law state? It states that the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media. Now students, the angle of incidence, which is denoted by I, and the angle of refraction, which is denoted by R. If we take the sine of these two and we take the ratio of the sine of these two, then it has to be a constant. That is, sine I upon sine R is a constant, which is also given by a letter mu, and this mu is the refractive index. So sine I upon sine R is always going to be a constant for a given pair of media. That is, if we have a given pair of media, then this ratio is always going to be a constant. For different pairs of media, the ratio is going to be different, and this constant is known as refractive index for that two mediums. So students, here let's understand what this refractive index means. Refractive index, it is the ratio of speeds of light in the two media. So students, the ratio sin I upon sin R, which we saw was equal to refractive index, is also equal to the ratio of speeds of light in the two media. How do we write it? We write it like this, that if I write mu2 1, that is, if a ray of light is entering from medium 1 to medium 2, then we write the refractive index like this, and we read it like this, that the refractive index of second medium with respect to the first medium is equal to the speed of light in medium 1 upon speed of light in medium 2. And if I denote the speed of light in medium 1 by V1 and speed of light in medium 2 by V2, then V1 upon V2 is going to be equal to the refractive index of the second medium with respect to the first medium. And since by Snell's law this mu was given as sin I upon sin R, so what we have is, students, that the refractive index can be given in both the ways. Either it can be V1 upon V2 or it can be sin I upon sin R. So students, the refractive index of medium 2 with respect to medium 1 is equal to the ratio of speed of light in medium 1 to the speed of light in medium 2. Now here keep in mind that the light is travelling from medium 1 to medium 2 and the refractive index is given with respect to the two medias, that is, the refractive index of medium 2 with respect to 1 is given by V1 upon V2, or it is given by sin I upon sin R. Now students, if we replace the first medium by air, or you can say vacuum, then this refractive index is called absolute refractive index. So absolute refractive index, which is denoted simply by mu, it is defined as the ratio of speed of light in vacuum or air to the speed of light in the medium. Now suppose, students, we have a medium and light is travelling from vacuum into that medium, then the refractive index of the medium is given as C upon V, where C is the speed of light in vacuum, which we have already read, and the value of C is 3 into 10 to the power 8 meters per second. Now here in place of vacuum we can take air also, because the refractive index of air and vacuum are almost same. So mu, which is the refractive index, here it is called the absolute refractive index. So mu, which is the absolute refractive index, is given by the speed of light in vacuum upon the speed of light in the medium. So it is given by C upon V. Now students, here we have a table showing the refractive indices of different materials. So let's study this table. Now here we have the name of substance and the refractive index of each substance. Name of substance and refractive index. Now if I observe this table, what I see is that the value of refractive indices are increasing. You can see this, that the values of refractive indices are increasing. Initially it was 1.003 for air, right students? Then for ice it is 1.31, for water it is 1.33, and the values are increasing. For the turpentine oil it is 1.47, then for glycerin also it is 1.47, then rock salt it is 1.54, for diamond it is 2.42. So what we see here is that the refractive indices are arranged in increasing order. Now students, the refractive index is ratio of speeds, so it is not going to have any unit, it is a unitless quantities. So we simply have numbers. Now students, here what we observe is that here the refractive index is simply giving us an idea about the optical density of the material. That is, on seeing this refractive indices, we can have an idea about the optical densities. Since kerosene is having refractive index of 1.44, which is less than alcohol, which is having a refractive index of 1.36. So what we can say is that kerosene is optically denser than alcohol. Similarly, what we see here is, we can say that sapphire having a refractive index of 1.77 is optically denser than carbon disulfide, which is having a refractive index of 1.63. Now students, here the highest refractive index shown in this table is that for diamond. It is 2.42, and the least refractive index here is shown for air, which is 1.003. So here this is the most optically dense material and this is the least optically dense material. यहाँ पे स्टूडेंट्स मैं आपको एक बात और समझाना चाहूंगी, यहाँ पर हम बार बार बात कर रहे हैं ऑप्टिकल डेंसिटी की। मास डेंसिटी एक डिफरेंट चीज होती है। एक एग्जांपल से आपको समझाती हूं कि अगर मेरे पास में केरोसिन ऑयल हो और उसको मैं पानी के ऊपर डाल दूं, तो आप सबको पता है, कॉमन ऑब्जर्वेशन है कि केरोसिन ऑयल की लेयर जो है वो पानी के ऊपर तैरने लगेगी। क्यों तैरने लगेगी? क्योंकि केरोसिन ऑयल जो है वो हल्का होता है पानी के कंपैरिजन में। अब जो ये केरोसिन ऑयल हल्का होता है पानी के कंपैरिजन में, इसको हम कैसे बोल सकते हैं? इसको हम बोल सकते हैं कि केरोसिन ऑयल की मास डेंसिटी वाटर की मास डेंसिटी से कम होती है। पर यहां पर अगर आप स्टूडेंट्स देखोगे तो केरोसिन की रिफ्रैक्टिव इंडेक्स कितना है? 1.44, और पानी का रिफ्रैक्टिव इंडेक्स कितना है? 1.33। मतलब केरोसिन की ऑप्टिकल डेंसिटी वाटर से ज्यादा है, जबकि केरोसिन की मास डेंसिटी वाटर से कम है। तो स्टूडेंट्स, ऑप्टिकल डेंसिटी और मास डेंसिटी जो है वो अलग अलग चीजें होती है। ऑप्टिकल डेंसिटी का मतलब हो गया लाइट की स्पीड से रिलेटेड, और मास डेंसिटी का मतलब हो गया मास से रिलेटेड, यानी कि वेट से रिलेटेड। सो स्टूडेंट्स, इन दोनों को जो है अलग अलग रखिएगा, अलग अलग समझिएगा। तो ऑप्टिकल डेंसिटी जो है वो हमें रिफ्रैक्टिव इंडेक्स से रिलेटेड समझनी है, और ऑप्टिकल डेंसिटी हमें ये बताती है कि किस मीडियम के अंदर लाइट ज़्यादा आसानी से ट्रैवल करेगी। जिसकी जितनी ज़्यादा ऑप्टिकल डेंसिटी होगी, लाइट की स्पीड उस मीडियम में उतनी ही कम होगी। यानी कि लाइट जो है वो पानी के अंदर ज़्यादा तेज चलेगी एज कंपेयर टू जो वो केरोसिन के अंदर चलेगी। मतलब क्या हुआ कि स्पीड ऑफ लाइट वाटर में ज़्यादा होगी, स्पीड ऑफ लाइट केरोसिन में कम होगी, क्योंकि केरोसिन ऑप्टिकली ज़्यादा डेंस है। सो स्टूडेंट्स, ऑप्टिकल डेंसिटी ऑफ अ मीडियम is directly related with the refractive index of that medium. A medium which has the highest refractive index will have the highest optical density and vice versa. Light will travel the slowest in the material which has the highest refractive index and travel the fastest in the material which has the lowest refractive इंडेक्स। सो यहां पर जो हमने टेबल देखी थी उसमें डायमंड का रिफ्रैक्टिव इंडेक्स सबसे ज्यादा था, यानी कि वो सबसे ज्यादा ऑप्टिकली डेंस था, और स्पीड ऑफ लाइट उसमें सबसे कम होगी। एयर जिसका रिफ्रैक्टिव इंडेक्स सबसे कम था, उसकी ऑप्टिकल डेंसिटी सबसे कम होगी, और स्पीड ऑफ लाइट जो है वो एयर में सबसे ज्यादा होगी। एयर और वैक्यूम के अंदर स्पीड ऑफ लाइट जो है उसको हम 3 × 10⁸ meters per second लेते हैं। So here students, we have understood about refraction of light. In today's video, we learned what is refraction of light. We saw the behavior of the incident ray of light when it changes medium. We saw that it bends towards the normal when the light ray travels from a rare medium to a dense medium, and it bends away from the normal when it travels from a dense medium to a rare medium. Then students, we studied about refraction of light through a glass slab, and we understood what lateral displacement is, and then we learnt about the factors on which this lateral displacement depends. Then students, we learnt about the laws of refraction, the two laws of refraction, and we understood what refractive index is. Then we learnt what absolute refractive index is, and we saw the table and got an idea about the refractive indices and hence the optical densities of different materials, of different mediums. Students, in our next video we will study more about refraction of light. Till then, stay safe, stay healthy. Bye.